knows a lot about the science stuff. Professor Dave explains.
Over the past several tutorials, we have been learning a lot about rocks. We have learned about the types of rocks, those being igneous, sedimentary, and metamorphic. We have learned about their origins, their mineralogy, and their properties. With all three types of rocks now understood, we are ready to examine something called the rock cycle, a construct which magnificently encapsulates a huge breadth of geological phenomena. All three types of rocks are slowly changed from one type to another in this process which we refer to as the rock cycle. This involves the formation and destruction of rock throughout geologic history. For example, in Earth's early history, all rocks at the surface were igneous, having formed from the cooling of liquid magma and pushed up to the surface. Over long periods of time, rain and wind would break these rocks apart and transport their sediments to the oceans, where they would be buried and later lithified into sedimentary rocks. In parts of the world where two plates were moving together, these original igneous rocks were metamorphosed by the heat and pressure of collision and uplifted to form mountains containing metamorphic rock. And just as before, these rocks were broken down and their sediments transported to sedimentary basins. These new sedimentary rocks would later be uplifted and exhumed, where they would again be attacked by the wind and rain, broken into sediment, and transported to a brand new sedimentary basin. In parts of the world that were experiencing subduction, the original rock in the subducting slab was returned to the mantle, where it would presumably sink to D double prime and later rise to form a mantle plume, which would melt, create a volcano, and erupt lava to form a brand new igneous rock that perhaps shares a few silicon or oxygen atoms in common with the rock from the previous iteration of the cycle. And then the whole show begins again. It is by these processes, which are collectively referred to as the rock cycle, that Earth continuously recycles geologic material, and in some cases, mineral grains from the primordial Earth have survived over 4 billion years of the rock cycle and exist today as parts of ancient sedimentary rocks. A famous formation in Australia, called the Jack Hills Conglomerate, contains detrital zircon, which is a particularly durable mineral that is over 4.4 billion years old. We can look at an image like this to summarize all of the possibilities within the rock cycle at once. We start with magma, which cools to form igneous rock. This could melt to form magma again, or it could experience weathering and erosion to form sediments, which can compact and cement to form sedimentary rock. Igneous rock can also experience high heat and pressure to form metamorphic rock. Sedimentary rocks can do the same thing if they are also subjected to such high heats and pressures. Then both sedimentary rock and metamorphic rock can experience weathering and erosion to produce sediments, just like igneous rock, and this sediment will eventually compact to form still more sedimentary rock. And metamorphic rock can also melt, just like igneous rock, to produce magma, and return to the source of it all. In describing the rock cycle and in talking about the production of sediments in general, we mentioned weathering many times, but we haven't gone into much detail regarding these processes. So let's move forward and talk about precisely how weathering and erosion transform rocks into sediment.
Thanks for watching. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.